We're going to do compound inequalities, which really are two concepts for sets. First, we have this concept, which is the union of two sets. If we want to think of one word to mean union, it means all. So for example, if I said I had the set that consisted of the numbers 1, 2, 3, 4, 5, 6, and I union that with the set 3, 6, 9, the resulting union is the set that has all the elements, but they only occur one time. They only occur once, so I would put in everything from one set, 1, 2, 3, 4, 5, 6. And then I look at the other set. I already have the 3, I already have the 6, so I put the 9. And that then becomes the union of those two. The other concept for compound inequalities is the concept where we call this intersection. This is the intersection of two sets. The word we think of for intersection is the word both. It is going to be the elements that are in both or common to both of the sets. Our example would be the intersection of 1, 2, 3, 4, 5, 6 intersected with 3, 6, 9. So for the intersection, we look what's common to both. So we see there's a 3 in both and a 6 in both. So our intersection is the set contains 3 and 6. There are words that we're going to use with our set notation that we've done that indicate a union, and that word is the word or. When you see the word or, that means intersection, and means union, and for intersection we look for the word and. So as an example, suppose I told you you have a set of all x values in the set of real numbers where x is greater than or equal to 3, and you want to union that with the set of all x on the real number line where x is greater than 5. We want the union. We'll use a number line so we can see what's happening. First set is all x's greater than or equal to 3. So if here's 3, then I have greater than or equal to 3. So I am shading in this area to the right because the absolute value is pointing right. Now I look at x greater than 5. So here's 3, so here's 5, and I shade in values pointing to the right from there. So looking at the union, it's everything beyond 3, including 3, and then we're putting in those all the values of the set that are greater than 5. Well, they're already there, so the resulting union is just x greater than or equal to 3. So we would write this as the resulting union is the set, and I'm going to write this in interval notation. It's the set 3, infinity. We're now going to take this same example, only instead of it being a union, it's going to be an intersection. So rather than write x is a real number, x greater than or equal to 3, I'm just going to shorthand write it like this. X greater than or equal to 3, and I'm going to do an intersection. So instead of writing the intersection sign, I'm going to write the word and. X greater than 5. So in this particular case, the and is telling us it's an intersection. So we're thinking the and is an intersection, so it's what's in common to both. To do this, I'm going to put in the number line, and I'm going to work each part. I have x greater than or equal to 3. We had already done this. If this was 3, it was including the 3, everything to the right. Now I have x greater than 5. Here's 5, so I don't include it. So for the intersection, we look at where is the shading common to both. So we have the blue shaded region and the purple. So sure enough, the common region is this. And that's everything from 5 on to infinity. It doesn't include the 5 because the 5 was not in the purple shaded region. So we say that this intersection just becomes the interval from 5 comma infinity. It goes from 5 all the way out. We're going to do another example, and in this example I'm going to look at x greater than or equal to 3, and I'm going to do another intersection, x less than 1. We're going to graph this just like we did before. We have x greater than or equal to 3, so it goes from 3, includes 3, so I have a bracket going to the right. Now the second is x is less than 1. Well, 1 is here, and less than, it's parentheses, but it's the order sign is pointing to the left. We shade to the left. For the word and, that's an intersection, so both have to be shaded at the same time. So thinking of this is an intersection. We see there's no way on this number line where both regions are shaded at the same time. So we would say there's no area where they're in common, and we write it with a 0 and a line, and that means the empty set. I'll go to the next page for another. My final example, I'm going to look at x greater than 1 or x less than or equal to 3. So the word or indicates that this is a union. So this is a union. And we will do a number line which is going to give us the information. We put in the number line. X greater than 1. Here's 1. So I'm greater than means I'm moving to the right. And because it's not greater than or equal, it's a parentheses. So we get x greater than 1. The next part, x less than or equal to 3. Here's 3. Less than is pointing to the left. Equals means it's a bracket. And I shade in everything to the left. The fact that this is a union means I shade in all the elements from one set, and then I go and I shade in all the elements from the other that weren't included. I now have with all of these that this will be the entire real number line. So the solution of this, it's all real numbers, and we'll write that as negative infinity to infinity.